Hey everyone, welcome to Dr. Frank's Finance World. I'm Dr. Frank the Bank, where I try to teach you something about finance so you can make money on it in the future. We're looking at risk and return here, part 2. Please be sure to subscribe and look up, get your notifications. There's more than 60 videos. By the end of summer, there'll be more than 100 trying to teach you things about finance. Look in the notes for links and websites. When things change, we try to put them there. So before we were looking at how to apply risk, if you will, to a standard deviation and line it up on an empirical rule so we can say how often an observation happened. Another aspect of the risk part of it is to say, hey, how risky is this company individually if we're going to invest in it out there? And that is called something that's covered really in something called CAPM out here, the capital asset pricing model. But this is essentially the required rate of return for a company if you're going to invest in it. And ultimately, when you're trying to value a company, you're going to be up here saying, okay, it throws off cash flows or dividends or something. But that's in the future. To bring them back to today, we need to earn this required rate of return between here and here before we bring it back. So we'll be dividing those by 1 plus our required rate. And if we have to wait 2 years for it, we want to get that required rate squared. So we use this actually when we do a lot of the valuation stuff in firms and so forth out there. So you find here's the equation. The required return is a risk-free rate. Everyone should get something just for not having access to their money. Plus, what this is many times is called a market risk premium out here, and is the return of the market minus the risk-free. And you scale it, if you will, by how risky your company is relative to the market, and that is called beta. And you find beta by regressing the returns of the stock against the market. Sounds a lot more complex than it actually is. So here is a 3 data point, year 1, 2, and 3 for the return of the market versus our company that we're looking at out there. And in the year 1, the market was at 15%. And our company was at 18%. So you see that data point here. Year 2 was -5 and -10% down here. And year 3 was 12 and 16. And when you line them all up, what actually happens is in a regression, you do something called ordinary least squared. And you're trying to figure out how far away these data points are from what the actual were for the market. And by the time you compare one to the other, and line it up like this, find the line that represents the least distance between a straight line going up through those points or near those points, you actually end up with beta, which is the slope of the line out there. So down here, when we ran the regression, you found out that the beta for this particular company was 1.44. So whatever the return is of the market, we're going to add 1.44 to it or multiply it by 1.44 times in order to find out sort of the risk you take for being in this stock instead of just the market. So how do betas play out? Well, if a beta is 1.0 relative to the market, it means the security is just as risky as the average stock market out there. If the beta is greater than 1, it is riskier than the average for the market. And if it's less than 1, it is less risky. So in this case, they do tend to fall between 0.5 and 1.5, although I've seen betas much, much larger and much, much smaller than that. But that's where you would tend to put them. And what our one from the last example on the previous slide we did, with the beta of 1.44, for a 1% change in the market, we would expect a 1.44% change in the stock, both up and down. So you can see it is a little more risky than the market. So what is this whole thing in parentheses that they call a market risk premium? It's the additional return over risk-free that you, the investor, are needed to compensate for assuming an average amount of risk. Just being in stocks at all, you should earn something more because they're risky. Its size depends on the perceived risk of the market investor, its degree of risk aversion. Through time, it's actually varied quite a bit. A guy named Pablo Fernandez does a worldwide survey actually on this, typically yearly. I get emails from him. But anyway, it ranges between about 4 and 8% depending on where you are in the world in any given year. And if we took the 1.44 beta of our high-tech company, assume a risk-free rate of 3% and a return of the market of 7%, the way the calculation would be, there's the risk-free rate, there's our beta. We take the difference between them to get a market risk premium. The market risk premium in this case would be 4%. When multiplied it through, we would expect an 8.76% return for bringing the stock. In other words, each of those cash flows from a slide or two ago, the first one we would divide by 1.0876. The second one we would divide by 1.0876 squared, and so forth. Anyway, it represents the required return that you'd expect from high-tech company there. So one last part before we actually get to the problems out there. We're going to form stock portfolios and calculate the expected return of those. That's pretty common in the investment side of finance, so it doesn't surprise me it shows up in the course like that. It shows us how diversifying among different securities lowers the overall risk. That's really the purpose of doing this inside of finance itself. Please be sure to send me emails and so forth to Dr. Frank's Finance World or to fsmith@jbawealth.com. So I look forward to the next part, and we'll get through that momentarily. Have a great day. Catch you later. Bye-bye.